Hello, everyone. My name is Tyler Snow. I work at Questel. We are a patent-based company. We do end-to-end patent services for anything, one-stop shop for your patent needs. One of those stops is, of course, translation services, and we translate hundreds, thousands of patents every year in multiple languages. Myself, I've been involved in the Questel Translation Services Department for 8 years. And in that time, I've been working as a localization engineer, which means I am in charge of various initiatives, some including translation management systems, development work for computer-assisted translation tools, and also machine translation innovations. At Questel, we party with third-party entities that are in charge of the main training efforts. Much of my efforts have been in cleaning, gathering data, making sure we have everything we need to train the engines, working directly with our third-party machine translation providers in tweaking and developing and evaluating the engines that we end up using to translate our patents. So part of my responsibilities is to look out for what's new and upcoming in the world of machine translation. And that lends very well into the presentation I have for you today. Some of the stuff that I would like to present today, I want everyone to kind of think of it as if we're at the start of our trailhead here, we're on a hike, we can look forward and see many different paths before us. And some of those paths have been tried, some have never been attempted, others might lead to dead ends. So that's kind of the perspective I want to present going into this, is that we don't really know exactly where the industry is going to go, but we can see what the potential next steps could be. And yeah, I'd like to point out some of those steps in this presentation. If you are also interested in staying on top of where the industry is at and you don't necessarily know where to start, where I kind of gather my information on the latest news is from various sources, research academia, social media stuff, conferences such as the one we're in right now. And yeah, so I'll show this slide at the end as well if you want to look at it a little more. But just know there are lots of resources out there that you can go to hear about what's going on. And this is where I've been gathering my information over, the past few years. Okay, so kind of talking at a starting point where we're at is the big thing is neural machine translation. Basically, if we're going to start a new project, let's say I'm talking to a client or talking to someone in one of my departments, and they say, hey, we need to spin up a new machine translation service for this product or this client or whatnot. It's kind of a given that it's going to be a neural machine translation engine. There are other options out there. Historically, there's been statistical, maybe rules-based, but yeah, it's de facto going to be neural machine translation. So with that, neural is not necessarily a new technology that's out there, but it's not necessarily an old one either. So I would say we are not in its infancies anymore. We've moved past that, but we are definitely in the more adolescent phase, but not anywhere near reaching full maturity on what we can do with this amazing technology that is neural machine translation. As with everything, we're always getting newer hardware and newer softwares that we're able to integrate into the process. With hardware, it's been quite interesting because there's kind of a major parallel between the work we're doing with building neural networks specifically for use in the translation space, but also in the realm of cryptocurrency. There's a major demand there in that whole space for better and better hardware in order to mine up those crypto coins. And that leads to better GPUs, better arrays of GPUs, and even some additional technologies. All of that lends very well into the space of trying to build up neural networks for other purposes, such as translation. I'd like to point out that with this hardware and with this software, we're able to get more and more nodes into our neural networks. We're able to get more layers, additional dimensions, perhaps, if you're familiar with. I don't want to get too into the details here. I'm trying to keep it more of a high-level discussion. And we're also able to do more training cycles, which I find as one of the more interesting things here. To kind of lend an understanding and like I said, a very general level. I'd like to use an analogy here. It's a bit strange, so bear with me. But I often think back to when I was in high school, studying for a calculus exam. And I think, okay, if I could replay that day over and over again, kind of like Groundhog Day movie scenario, and try different ways of studying that day, kind of cramming for the exam. If I tried different methodologies, I wonder which one would work best. Um, and that's kind of how it is with training neural networks as well. We try kind of a bit at random, training different ways over and over and over again. At some point, we have to decide, well, this is good enough. Even though it may not be perfect, this is the best that we can do. And then that's the network we go with. A lot of people think of neural networks as these smart, thinking entities, but really it's more like as if you studied all that time and then you took a snapshot of my brain at that time and you just saved it. And anytime you needed to run calculus, you were able to run it through that brain. Granted, on my calculus, I did pass the test, but I did have some flaws, and those flaws would be inherent in our snapshot of our neural network as well. So keep that in mind. It's kind of a dumb process, really. Trial and error over and over again. So another thing that's really cool about this, though, is that with these additional hardwares and software options that are becoming available, we are able to better train. But like I said, the most important thing is that iterative training process. We can add more days to that cycle or more attempts to come up with a more perfect neural network. We're also getting better at directing those iterations in a more focused way. So for instance, we know that there are certain alignments of neural networks that are just straight up not going to work for us. So we can skip those and focus on the ones that are perhaps more productive. Another thing about the crypto industry that's very interesting that I do not see in our space yet, but could be coming in the future, is the ASIC option. So for those of you that aren't familiar, GPUs they were initially developed for gaming processing, for passing video streams at the most efficient manner, but they were really, really good at processing large amounts of text, so people kind of co-opted them for other purposes. But they were not specifically designed to mine crypto or to create artificial neural networks for translation. But that's kind of what we've been using them for. But imagine if you went all the way back to the start. Let's say you work at like an IBM or some sort of hardware manufacturer. You said, okay, scrap everything we've done. We want to go from the beginning. This is our goal. We want to train artificial neural networks that are really good at processing text. And so they design the circuitry from the ground up to do just that. And in the crypto space, there are many coins where it's become so complicated that they are unable to use those general neural networks, and they are specifically relying on those ASIC hardware setups designed specifically for mining cryptocurrency. I don't know if there's necessarily quite as much of a financial incentive for companies. Maybe some of the larger companies in the translation space would look into something like that, but that may be something you see in the future, maybe from a Google or a Bing that are in that machine translation space that have the bandwidth to be able to create those hardwares from the ground up. That would be new and innovative for sure, and would greatly improve the training cycles and the layers and all of that stuff. Yeah, definitely think of it as we're entering the era of 4K television, but for translation space. More nodes means more ability to get into, more granular, more detailed outputs, let's say. Yep, with that, we're able to adjust the parameters a bit. We're able to play with more of the weights and biases and incorporate other things such as linguistic checks into the process. We're getting better not only at working with the hardware and software, but we are getting better on the front and the back ends, stuff that I focus on more, which is the data feature creation. So neural networks don't really have a concept of text. Text processing has to all be boiled down into ones and zeros for our neural networks to even function. And so we have various creative ways to be able to break down the text, the source text, and the target text. A lot of times that involves, making snippets of the text, what we call n-grams, like 3-word chunks, 4-word chunks, stuff like that. But we're getting even more creative to mixing around, like perhaps look at the first 3 words and then the last 3 words and add those together and making different combinations of text, but also looking at information around the text as well. Like, for instance, who said that text? Or how long is it? What sort of stuff is in there? Are there chemical formulas in there? Different terminology. So incorporating that into the node training process for our neural networks is leading to some interesting results. But there's a lot of different ways that we can slice and dice our data, and there's really a lot of work to be done in determining what the best options are at slicing our data and training it. There's also a lot of work in the data cleaning and data generation spaces. A lot of times, especially in resource poor languages or even resource rich languages, like for instance, kind of depends on a company by company basis. Perhaps your company doesn't do a lot of Chinese, but obviously there's a lot of data out there. Or maybe you want to really control what terminology is used in a particular space. Well, in order to train your neural network, you may not have enough examples to train the engine exactly how you want to train the engine. So there's certain techniques such as duplication of existing data, just adding more of the same segments into the training set, or even tweaking those segments a little bit with some fuzzy match generation. So for instance, you'd say something like, our company has 12 computers. And then you could generate another segment that says our company has 12 chairs or something like that. But just tweak the existing segments, adding additional terminology or additional phrasing that maybe you want to add into your neural network. That's a little more like artificial training data, but that is a very good technique that we're getting better at and seeing some results. Then, of course, traditionally terminology has not been a given in the neural network space, but I see a lot more that it's becoming mainstream to add in terminology lists into training sets and maybe being able to adapt the engine outputs based on terminology sets or for different scenarios. So that's something that in the past we've had with statistical and with rule-based engines, but wasn't initially a real easy thing to do in the neural network space, but it's becoming easier. So yeah, conclusion on the neural network space, we definitely have a lot of things we can try. A lot of things are being tried, and we're seeing improvements all around. So expect that to continue in the future. All right, so moving on to a slightly different topic. This is a little more of, I don't see it as necessarily mainstream. I see a few people talking about this. And so I don't necessarily have a good title for it, but I'm going to call it contextual smoothing. So for those of you who are familiar with computer-assisted translation tools like your SDL Trados, your MemoQ, maybe a SmartCat, there's plenty of them out there. So a concept in that space is fuzzy matches or context matches. So imagine you do a translation, you have your source text. In this case, I have some Chinese up here at the top. And imagine there's another language on the side, maybe English or something like that. So the first translation happens, people translate from scratch, it goes into the memory, and then the next time a project comes through, let's say that this segment appears in the new project as well. Oh, let me go back here. Sorry about that, skipping ahead. Wants to skip ahead. Okay. Yeah, so imagine we have this segment right here, again, in the new incoming project. Therefore, we've translated in the past, and the computer-assisted translation tool applies a 100% match. Well, in the memory storage space, from the first project, we've also stored a bit of contextual information, such as the segment before and after. Now, assuming the new project has not only this particular segment, but the previous segment also matches this previous segment in the previous project, then we know that this is a memory match, but kind of even more so, we know that we've seen this segment before in context. So traditionally in neural network machine translation, NMT, we kind of just throw memory matches at it without any sense of context. So this segment will be trained, it has no idea what comes after. This segment will be thrown into the mix. It doesn't have any idea of what comes before or after. But that paradigm is kind of changing. So if we're able to preserve the context and get information from before and after segments, then we're able to use that to further train our data and tweak it to be a little more accurate. And there's lots of different levels where this can apply. So like I've mentioned, the surrounding context of the segments in question is useful. You can look at whole paragraphs or sections, which is very useful. For instance, in the patent space, we have lots of different sections. There's one section that's like an abstract, kind of a summary of the whole patent. You have your spec, which is going to be the entire description of basically the patent itself, and then you also have a list of claims at the bottom. That's really important to list out what exactly you're trying to cover with that patent. So we have different sections that are very distinct, and we can incorporate those into this context training of the engines. I have seen a lot more talk, especially in the academia space, where they're considering the whole document, both the textual information there, perhaps the terminology used specifically, and also metadata information, such as, okay, this is a chemical patent, for instance, in my space, and therefore you can use that additional not in the text data to train your engine as well. One of the even more interesting things is that we're also starting to consider the subsegment level in our neural network trainings as well. And you can see that in technologies such as the Trados uplift technology. Somewhat old news, but if you're familiar with that, it will allow you to, as you're typing, it will fill in, I guess, basically like suggestive text. Like you start typing and it'll say, okay, well, this is probably the translation you're looking for, and you can fill it in at the subsegment level. So there's a lot of that. And then there's also some correction as well, which is kind of leading into the adaptive NMT section. So since we're on the topic of uplift, there's also another factor, and I think it's called something else. Maybe I've got my terminology switched around there. But basically, we get output of fuzzy matches or machine translation output, and their uplift technology will attempt to correct that, kind of like a pre-post edit for your translators. It tries to bring it up to the 100%, like doesn't need to be changed at all kind of level. So like I think an example, our company has 12 computers, but the text requires Our company has 12 chairs, and it's able to identify, oh, you just need to change the word chairs. And I know that you're looking for computers. You've translated that before. Let's plop it in there. And then a human can come through and look at it and, give it the stamp of approval at that point. And that's sort of the idea behind one of the newest buzzwords in the NMT space, which is adaptive NMT. And what I found when talking to people about this is that they're really talking about a bunch of different things. There's not really one real consensus about what adaptive NMT is, as far as I can tell. But the basic concept behind it is that you're going to be changing your NMT output based on lots of different things. So most likely it's going to be you're changing the terminology because of the context. And the context, like I said before, can be an implicit or an explicit thing. So you can have systems that are able to identify based on what the text has in it, like these words are being used, these sections are being worked on, et cetera, et cetera. And you're able to adapt the output on a case-by-case basis. Or it could be explicit, like I mentioned, this is a chemical patent, therefore use this output, something like that. And there might be a lot of different reasons why you want to do this. Perhaps you want to train an engine specifically or adapt an engine that is on a client-by-client basis. Maybe you have a lot of data for one specific client. You can get a lot closer to their desired output versus maybe your general engine that has, the whole world as a training set. Maybe you want to change the post editor's voice. You want different outputs, or different people want to tweak the outputs based on their own personal preferences. Maybe I've mentioned domains a lot. Like you don't want your engine outputting the same terminology for your chemical people as your automotive, manuals or something like that. You have the locale of the target audience. This may be important. We have, for instance, Spanish from Mexico and Spanish from Argentina. Are we going to want this engine outputting, the same way of phrasing things for those both those unique locales, let's say? So let's talk a little bit about how this works. And I have another strange example for us, but imagine these aren't necessarily comprehensive. There are other methods to adaptive NMT, but these are the main ones that I've talked to people about. First off, it can be kind of straightforward where you just train multiple engines. And like here, I've made multiple sandwiches, perhaps one for my chemical patent space, one for my automotive, and one for my, I don't know, some other domain. And every time I get a request for translation, it'll come through, say it's English to Chinese, and I have all of these 3 different Chinese engines. It'll go through and select the appropriate engine for whatever context I'm looking for. Another way to do this, and if you're familiar with the new, kind of new, not necessarily new, but the Google NMT option, where you are able to upload your own training materials and adapt Google to to your specific needs. Kind of how that works in a way is Google has billions and billions of training segments that it has to work with. And you come along with your, maybe, let's say you have a good set of data, 100 million words or something like that. Well, in comparison, that's not really going to affect Google all that much. And so they kind of take a different route with that. Instead of training up the whole neural network from scratch using all of the previous data that Google has and your little teeny additional sliver of data in comparison, they'll instead focus on training some of the hidden layers here. So they may adapt just one layer, and that way your training data will have additional weight. But that's kind of the idea as well. So instead of training a whole new engine each time, you just come in and in my sandwich example, you just change the outer layer, the crust there. And that way you're able to adapt just the weights and measures between these nodes on a much smaller scale. But if it's towards the end near the output layer, then it is a little more impactful. So that's kind of a way to do that as well. And then, of course, you have just adding additional rules to the output of the engine. And that's kind of like you order your sandwich from the restaurant, you take it to your table. The people working there aren't going to change anything of your sandwich, but at the table, you have some salt and pepper, and you go in there and add those on after the fact. Some people would say that's not really changing anything. And other people would say, well, that's like you're using a hybrid model at that point. You got a rules-based process on top of your NMT engine, and that may be true. But yes, I see that sort of thing happening and not really being talked about or addressed, but it does definitely happen, especially when working with terminology. You want to just tweak the terminology after the output. So yeah, lots of different ways that people are adapting their NMT processes and changing the outputs. And I can see people doing a lot of research in this space, and us included. We're looking to, use our data, perhaps use combinations of these techniques in order to get the most optimal output for a given situation. One of the things that is really speeding up the whole training process is I see a lot of these computer-assisted translation tools out there. They're integrating machine translation into the process. So they're able to perhaps do that adaptation in real time. So as people are working on the translations, we're able to tweak the output, use different terminology, something to that effect. But also, we are able to gather in a more real-time scenario, what is being changed? How quick are these? How much effort is it working on these segments? And we're able to build up that sort of all of those changes, store them up, and do either a complete retraining or an adaptive retraining on our engines and our processes. So I totally expect this to be a thing, more integrations into existing tools of machine translation technologies and really interfaces. So skipping ahead here, one of the things that is a challenge in this space is oftentimes we will use what is called golden text to do our training processes. We have to have some good examples of some good text in order to train our neural machine translation engines to match what is considered the golden text. This is not as clear cut as it seems, however. There's lots of ways to measure how much effort is going in to interacting with our machine translation output. And we have different ways of measuring this as well. So oftentimes we'll take a look at, okay, we'll run source text through the machine translation. We got the output, we give it to some translators, they work on it, change things. And then after the fact, we'll look and say, well, how much of the text was changed? And usually we're able to boil that down to a percentage, but there's a lot of controversy in that space. There's lots of scores out there. You got your tier score, you've got your blue score, and kind of the debate is how much effort is it to, for instance, let's say we don't change any of the word, but we move that word from the beginning of the sentence to the end of the sentence. Was that more work than keeping the word in place but swapping it out for another word or fixing 3 character mistakes or something like that? It's not very straightforward. So oftentimes I like to look at multiple scores in order to get an idea of, these are all measuring different things, but are the scores improving overall? We also like to look at how long did it take to fix things. So that translator changed some text. How long did it take them to do that? And were they working on that segment for 10 minutes? Were they working on it for 1 minute or whatnot? And oftentimes I find that these 2 data points don't necessarily correlate. We had just a great example just last week of we had a new machine translation system that came in. We did an evaluation. We looked at these 2 data points, and we found that they were making much less edits on the new potential engine that we wanted to use. but it was taking them a lot longer to make those fewer changes, and that was very strange. So we did a little follow-up and found out that, okay, everything that the new machine translation was saying was indeed accurate. It was fluent. In fact, the fluency was a lot better than the previous option, the older engine. But the way that they were saying things was not what they were used to. And so it took them a minute to read the text and say, is that good? Uh, and in a way, it's not what it was saying, but how it was saying it. They didn't like that, or they weren't used to it. So that's kind of an indication that if we were to look at those data points now, the engine would be questionable, but that's a good indication that in the future, more than likely, the time to interact with that machine translation output is going to improve as our translators get used to working with it. Going back to kind of the starting point of this topic, specificity matters. What I mean by that is rating translations as good or bad is kind of like rating art. Down here, I have a couple of masterpieces from, a couple of artists here, and we can both kind of argue as to which is the better painting, or it's very abstract. But as soon as I specify, well, which is the painting with the most shapes in it, instantly there's no more debate. So the better that we're able to specify, the better we are able to come up with what is exactly the translation that we are trying to mimic with our machine translation system. And there's a lot of work being done in this space, especially if you've heard of machine or multidimensional quality metrics, MQM. That's a way of being able to determine what is the yardstick, at least on a context by context basis. It's not a way to create a universal measurement system. But anyway, lots of improvements going on there. I also see a lot of inclusion now of automatic checks, stuff that you'd think, oh, we probably should have been doing this from the beginning. For instance, in our cat tools, we were able to check our translations for punctuation and use of wrong numbers and stuff like that. But I don't see it often used in a neural machine translation checking, at least to see if the engine is good. But there is a trend towards including things like these verification checks that are automatic into the process. So lots to do there. And there's obviously a ton of different things that you can check. Determining what's the best is good. Quickly, I'd like to go over, I know I'm kind of getting over time here. So much great stuff going on in the translation industry. But kind of to finish up with one of my favorite topics, I see we've talked a little bit about determining the quality of our output. But what if we could determine the quality before a human started working on it? Similar to our fuzzy matches, we know how much effort it's going to take to get a fuzzy match from like an 85% to 100% what we need for that translation. And with our neural networks, we were able to train up a network perhaps that looks at the data, the before and after data for the post edits, and we can come up with a determining, we can go back and say how much was changed between, the raw output and the post edit output, and come up with a number, say, okay, that's a segment that is going to require 15% changes, or maybe we don't even go to that level of granularity. We're able to say this output is probably going to be hard for our system. This output is going to be easy for our system. And that lends itself to a couple really important things. For instance, that's going to change the dynamic in billing and sending out projects to vendors. For instance, we can say things like, hey, don't spend a lot of time on what the system knows are going to be easy segments. Right now, they have no idea. You just send a machine translation output, and they don't know if it's going to be hard, if it's going to be easy, take a lot of work until after the fact, but we're going to know that beforehand. Obviously, we can charge more for the segments that are more difficult and less for the ones that are not going to require as much. And going back to our adaptive NMT, this really is going to enable and ensemble engines. So for instance, we have those 3 engines. Maybe we run the source text through all 3 of them, even if it doesn't necessarily make sense to do so. But we're able to measure, okay, which engine gave us the best potential output within a degree of reason, and then present that to a human to post edit, or if it's good enough for whatever context, that will be the final translation. Yeah, so like I said, final conclusions, NMT is here to say we're improving things with our data cleanup before we train the engines. We're cleaning things during well, not cleaning, but improving our way of interacting with NMT options. And we're also improving our methodologies with interacting with the output and then feeding that back into the training cycle. So completing the whole loop there. I don't think there's going to be a question and answer session, but this will conclude my presentation. If you have any additional questions for me or would like to reach out on any topic, my email is there at the bottom, tsnow@questel.com. Thank you very much for your attention, and I hope to meet you perhaps one day in person at a conference when that is once again a thing. Thank you very much.